This video is on Unit 2 Biochemistry. This is the first of a few videos for this unit, and this one will just cover basic chemistry. So, here's your vocabulary for this unit. It's also listed on our Google Classroom page, so you don't have to necessarily pause at this point. I just wanted to kind of give you an idea of some of the terms that we'll talk about in this section of notes, as well as throughout the section on biochemistry. Alright, so to dive right into it, why is chemistry important when we talk about biology? Because it's kind of the foundation of how everything gets put together and how we work at our most basic level. And the basic unit of matter is called the atom. And it's composed of three parts: a proton, a neutron, and an electron. Protons are positively charged particles. Neutrons carry no charge at all. And electrons are negatively charged particles. All of the protons and neutrons of an atom are found in the center in what we call a nucleus. I didn't include this word as part of your definitions because it gets confusing when we start talking about the cell. But the center of an atom is made up of protons and neutrons. So the center of the atom, or the nucleus, is positive, and it has around it constantly moving electrons, which are negatively charged particles. So there's this attraction between an electron and the protons of the nucleus, but because the electrons are constantly moving, they never attach to the protons of an atom. Chemistry is divided up into elements, and an element is a pure substance that consists entirely of one type of atom. So a pure substance may be hydrogen or helium or neon. And all of those are completely one type of atom. They bond to each other in unique ways. So carbon's atomic number is 6, meaning it has 6 protons and 6 electrons. So it has a 0 charge, because if a proton is positive and an electron is negative, 6 positive plus 6 negative leads to a neutral charge. All elements are going to be that way. They're going to have that neutral charge with 6 protons and 6 electrons, or if it has 18 protons, it's going to have 18 electrons. An isotope is the same element, but it differs in the number of neutrons, so it's going to weigh a different amount. If you remember, an atom is made up of protons, neutrons, and electrons. Protons and neutrons together make the nucleus of the atom. And the mass of an atom is determined based on the weight of that nucleus. So an isotope means that it has more neutrons. The charge hasn't changed at all because neutrons are neutral. So the mass number is different, but the charge is still neutral. And mass number is protons plus neutrons, all found in the nucleus of an atom. So a quick important key on isotopes is that because they have the same number of electrons, they all have the same chemical properties. But as you'll see in just a second, we can look at isotopes and use them for different purposes based on some other properties that they have. Alright, so radioactive isotopes are unique in that the nucleus of the atom is unstable, and it's going to break down at a constant rate over time. So we use radioactive isotopes to do radioactive dating, which measures how old a rock or a fossil is by determining the isotopes found in them. So if there's carbon-14 in an isotope, which means it's a carbon atom, but instead of weighing 12 like it normally does, having a mass weight of 12, it has a mass weight of 14, meaning it has 2 extra neutrons in the nucleus. We use that carbon-14 to analyze the the age of the rock or the fossil. So this does have a very important biological function. And by doing this radioactive dating, we can determine when something was alive and plug that into some other theories, just to kind of give you a big picture, plug it into the theory of evolution. So where did organisms come from? Where's their common ancestor? All due to radioactive isotopes.